Good morning, students. In previous class, we have gone through looping control structures, while and for control structure. How can we use the while and for solving different types of problems, which are an iterative, which are allowing an iterative set of statements to be executed repeatedly. So loop means executing the set of statements repeatedly until a specific condition becomes false. So, but in looping control structures, which we have seen earlier, those are all using vectors to perform a set of tasks. In for, we are using the vector consists of a set of values. And until the sequence becomes empty, we have to repeat the statements that should be executed a number of times. When we are coming to other side of looping control structures, those are nothing but non-vector sets. Non-vector sets means the elements which are not a part of vector, which are individual or two-dimensional or any other format other than vector structure. When we are using other formats of variable structures, then how can we use the loops in those type of variable representations? Variables means objects in R. So in those type of non-vector object representation, how can we use the loops to repeat or iterate the set of statements continues? So that we can see here. So already in looping control structures, we've gone through for loop, while loop, and other statements which can be used to skip or break the loop structures. Those are break, next, and repeat. Repeat is equivalent to unconditional control structure. That is repeating the set of statements. That is allowing repeated execution of statement without depending on condition. That is in syntax we are not having any condition that has been specified, but we have to specify the condition for termination. So see an example of recursion. When we are using the recursion, example for recursion is factorial. So we are calling the function repeated number of times until a condition becomes false. That is, we have to specify a termination condition for recursion. So, but in recursion, there is no condition by default specified in syntax. So, when the for example, factorial function value that when n reaches to 1, then factorial function recursion can be terminated. And similarly, here also, you have to specify a condition using break statement to terminate the repeat. So in syntax of repeat there is no condition, but for termination user should specify the condition. That is the difference between other looping structures and repeat. So next coming to the non-vector set representations for solving different types of problems. How can we use the loops in non-vector? So looping over non-vector sets. R does not directly support iteration over non-vector sets, but it indirectly supports non-vector. That is nothing but it is not directly having any syntax representations or any control structures which can support non-vectors. But there are a couple of indirect easy ways to accomplish non-vector set evaluations using loops. So the first function we are using is apply. So an apply function applies on two-dimensional arrays, that is on matrices or data frames to find aggregate functions like sum, mean, median, standard, those are nothing but these statistical functions. So statistical functions, calculations, we can use the apply function for a two-dimensional matrices or for data frames. So the syntax for apply function is apply matrix margin function etc. The other arguments are optional. So margin equal to 1 indicates row, margin equal to 2 indicates column. So compulsorily you have to specify for apply function the matrix and margin values, and other parameters are optional. So here we are taking an example how we can use the apply function in matrix operations. So creating a matrix X with a range of values 1 to 20. Range of values 1 to 20 means this is a two-dimensional structure arranging 1 to 20 values in number of rows 4 and number of columns 5. That is 4 by 5 dimension. So 4 into 5 equal to 20. So here arranging those elements 1 to 20 in column format, not row format. So displaying X. So displaying X value. When we are using the apply function on the created matrix, here apply X matrix 2. 2 indicates column. So 2. What is the function we have to perform? Sum function. That is sum of the column values. So you can check here. In this matrix, we have to perform column addition. That is the column wise sum. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Okay. Next, 5 plus 6, 11, 11 plus 7, 18, 18 plus 8, 26. Next, 9 plus 10, 19, 19 plus 11, 12, 30, 30 plus 12, 42. And next, 13 plus 14, 27, 27 plus 15, 42, 42 plus 16, 58. Next 17 plus 18, 35, 35 plus 20, 55, 50 plus 5 plus 19, 72. So this is how can we use the apply. You can apply these in the same matrix using row wise addition also. You can check by applying them. So apply function is always used to perform after operations on matrices, statistical operations by using the syntax of apply function. And another one, lapply. Use lapply assuming that the iterations of the loop are independent of each other. That is, instead of performing either row-wise or column-wise operations, if we want to perform the operations randomly, then we can use the lapply function, thus allowing them to be performed in any order. So lapply can be applied on data frames, lists, vectors, and returns a list. So lapply returns a list of same length as X, each element of which is the result of applying function to the corresponding element of X. So lapply can be applied on any, not only on matrices, it can be applied on vectors, lists, data frames, etc. So syntax of lapply, that is X, which is either data frame, matrix, or vector, any other. Next, what is the function we want to apply? So here, matrix 1 to 4, number of rows 2 and number of columns 2. So 2 by 2 matrix with 1 to 4 elements. So this is the matrix 1, 2, 3, 4. If we are not specifying either row measure or column measure, then our elements can be arranged in column measure. Then here we want to calculate square root of elements of X. So lapply X square. So here the calculations can be done independently on each element instead of either row wise or column wise. So square root of first element 1 is 1. Square root of 2 is 1.414214. Square root of 3, square root of 3, that can be displayed here. 1.73, etc. And again, and for square root of 4 is also displayed at the bottom, that is square root of 4 is 2. So this is displaying independently each element's calculated value instead of either row measure or column measure. So means LFI is used to apply a specific function on any set of elements in any order randomly and independently. So this is the difference between apply and LFI function, which are used to perform operations on two-dimensional matrices instead of vectors and lists. Another function, that is use get. Its name, that is nothing but get function. Use get, as its name implies, this function takes as an argument a character string representing the name of some object and returns the object of that name. It sounds simple, but get is a very powerful function. But since get itself is a simple function similar to other functions, but performance and evaluation of get is very powerful than the other functions. So syntax of get is get always gets, so here get function always receives the argument in form of character string. So syntax get of character string in quotations. Get sum. For example, get sum. So here get function that is always used to and returns the object of that. This takes the name and returns the object. So here name of this function we are passing is nothing but sum. So this is displaying the object structure, that is function sum. Na.rm equal to parts.primitive sum get g. So here we are defining the function x get sum. Here you can define the form. This is displaying the format of the function. Then you can specify the function definition get. Here we are specifying a get of the function name is g. So user defined functions can be created and those can be called using get function. Here we are creating the function with a name g. Function x, that is from get g. Under get g, here we are defining the function that is function x, what is the argument we are passing? Return x plus 1 get number. This is in form of x, we are passing number. So that is displaying the number. What is the value here we are passing? That is displaying the ASCII code of that value. So get always replace the function name and returns the object of that. Next, coming to what are the different types of reserved words which we cannot use as variable names in R. Reserved words in R programming are a set of words that have special meaning and cannot be used as an identifier, that is a variable name, function name, etc. This list can be viewed by typing help in reserved. If you are typing reserved, automatically that displays a set of reserved words. Those are if, else, repeat, while, function. So if, else, repeat, while, these are control structures. Function itself is defining the function. For next is also control structures, looping control structure. In is used in for loop, variable in sequence, and break, true, false, null, infinite, not a number, NaN, not assigned, NA, not assigned integer, NA real, NA complex, NA character, etc. So these are nothing but the set of reserved words which we cannot use as variable names. Next coming to the if control structure. Next control structure, already the looping control structure we have used for while and unconditional control structure, that is repeat. Next coming to the conditional control structure. It is not a loop, a single executable control structure. So the difference between looping control structures and This single conditional control structure is this executes a set of statements similar to looping control structures when the condition becomes true, but the statements are executed only once. But in looping control structures, those are executed until condition becomes false. That is the difference between these two, loops and condition control structures. So here the syntax of this is if condition, then execute set of statements. That is one format. And second format, if condition, execute statement 1, else execute statement 2. So this is the syntax of if and if else control structure. Next we can see the example. This is the flowchart representation for it, only not if else. So in it, first we have to check the condition test expression. If the expression is true, then execute, that is nothing but statement 1 or body of it. If the condition is false, come out of the loop and execute the normal sequence statements existing in the program other than the control structure. So this is the flowchart representation for it. Next, this is the flowchart for if else, that is the second thing. So executing set of statements if the condition becomes true, and executing another set of statements if the condition becomes false. So test expression. If the expression is true, then execute the body of it. If the expression is false, execute body of else statement. So here this is provided two executions, one for true execution and one for false condition. One for true condition and another one for false condition. But in normal use, only we are specifying the statement should be executed if the condition is true. No else partition. Normally, if the condition is false, coming out of the loop and go to the normal execution of program statement. So that is the difference between if else control structure. So we can see an example program. Example. Here, value we are passing in x is 8. If x greater than 3, then we are displaying y is 10. Else y is assigned with 0. So when we print y, that can automatically display the value 10. That is normal. This is only if. Coming to the else, y is assigned with 12. If x greater than 3, then otherwise 0. Then if we are displaying y, this can display an error. That is, if else cannot be used combinedly as a reserved word in math. So for that one again, we are defining another syntax. X is 4. If x equal to 4, x is assigned 1. Else x is assigned 3, y is assigned 4. So here this is executed and y is printing y equal to 0. And when we are executing this font, this is displaying error. And when we are executing this and displaying x and y, those can display. X is equal to 4, those are displaying x equal to 1. X is not equal to 4, then those are displaying 3 and 4. So when we are executing those set of statements, this output is for the third one. This is for the first one. Output is error for the second one. This is displaying if else is not used as combined. That can be identified by the R parser. That is, this is the initial structure. A trace should be used to separate both if and else. So third one is output 0 because here we are not displaying any value. Simply we are evaluating and that is displaying output. If we are writing any print statement that can display the values because syntax is here. Correct. And next, an if-else statement works as a function call and as such it returns the last value assigned. So this is the normal structure we are using while we are getting an error. So this will set V to the result of the expression 1 or expression 2 depending on whether the condition is true. You can use this tag to compare to the written example. So when you are using this case compulsorily, you have to specify the braces if you want to write those in a single statement for condition. You should not use if and else both at the same time. So that is the error why we are displaying another in the previous statement execution. So you have to use in this format x is assigned to b. Y is equal x is equal to 2. Display x else x is 1. So you can use this also in single structure but with a proper syntax. So if you are displaying in proper syntax, then you can get the output. If you are displaying y, you can get y equal to 3. Otherwise, y equal to 3. And again, here, if x is assigned to 2, if x is equal to 2, y is assigned to x, else y is assigned. You can use any one of these two syntaxes. You can get the same result. That is, you can check the condition and pass the value to the right hand side variable, that is one. And second one is set the condition and next initialize in the statement, that is the another one. So this is the variation of representing if else. But you cannot use directly if and else at the same time in the control structure syntax. So that is the difference between if and else is control. So this is actually the remaining part of looping over non-vector. So you can try another examples also. So that is here. You can check x if x by 10 or x by 2 is equal to 0. Then x is given, else x is y is there. Your quotations, using quotations, you can pass y, else y, and display y. So you can use the same structure representation for different types of tasks, real numbers, odd numbers, display, and other formats of tasks. So this is up to the looping over non-vector variables or sets. And in the next class we can see operators and functions.